Welcome to Space to Ground, and welcome to the Space Vehicle Mock-Up Facility at NASA's Johnson Space Center. This is where astronauts get to train on full-scale components of space vehicles. Every detail down to the switch is as close to the actual flying vehicle as possible, so when they get to space, everything feels and looks familiar. One of the latest mock-ups here is Orion, the spacecraft that will take the next humans to the moon again for the first time in more than 50 years. 4 human beings will be aboard Orion during the Artemis II mission, 1 Canadian and 3 NASA astronauts. They'll sit right here where I'm sitting, but in a real deal Orion spacecraft bound for the moon. We've actually been preparing for a return to the moon for a long time. The work that we've been conducting aboard the International Space Station has been crucial in our future lunar missions. To learn more about the research we've been doing with astronauts on the International Space Station missions, we're joined by Steve Platts, the chief scientist for NASA's Human Research Program here at NASA's Johnson Space Center. Steve, thanks so much for joining us. I'm sure you could name hundreds of experiments going on aboard the International Space Station that have to do with human research. What are some that come to mind?
Yep, quite a few going on right now. And one I like to talk about is studying the immune system. So, after the pandemic, we're all used to talking about immunity, but we know that the immune system changes in spaceflight. We saw it in shuttle, and we've definitely seen it in space station. We want to know how that will change going to the moon and especially going to Mars. We're looking at blood samples, see if any of the chemicals are changing, and then we also look at the cells. How do the cells respond to that time and space, to microgravity?
So it sounds like cells and immunity is a biology experiment. But do you have other biology experiments going on the space station?
We do. We collaborate a lot with the space biology program, and we have an experiment called Veggie that we're really excited about. And in that experiment, space biology is interested in how do the plants grow. So how do you package the seeds? What type of media do you use? How do you water them in space with no gravity? What we're interested in is the human component. So what is that countermeasure to growing the plants? We've actually had crew name their plants. They get really attached to the plants as they're growing them. They talk to their plants, but then the psychological countermeasure, the benefit of eating a fresh salad in the middle of your mission is huge. And then also the nutritional benefit that we have from growing our own crops. And as we think about going to Mars, long-term missions, will we have to grow crops there as well? So this gives us a head start on that.
So it sounds like they actually get to become space farmers.
They do, but no potatoes yet.
Sounds like there's tons going on in microgravity that we're researching. What about here on Earth?
Yeah, it's really expensive to do experiments in space. You have to fly all the equipment up, you have to bring samples back, and you have a limited number of crew members that you can have access to. So we have facilities here on Earth that we call analog. Some of them are for isolation, simulating that closeness of a small group of people in a confined space where you can't really get out. And then we also have a bed rest facility in Cologne, Germany, where we study the microgravity aspect. So we put them at 6-degree head down tilt for several months at a time, and then study how that fluid shift and how that deconditioning affects the human body.
Wow. So in addition to the ones you mentioned, I know that we've got our CHAPEA simulated Mars mission.
Yep.
So it sounds like we get to study isolation and confinement without even leaving the Earth.
We do, yes.
So Steve, I wanted to ask you, I heard that when astronauts get home from the International Space Station, as soon as they land, they have to do an obstacle course? Is that true?
Yeah. We've had several experiments like that, and the ones we're doing now, they're designed to look at the sensory motor system. So that's your sense of balance, your what controls your gait, how you walk, how you perceive the world up and down, and those kind of things. And we know that changes in space flight. And the longer you're in space, it's likely the worse that could be. So we're studying that now, where we do obstacle courses before flight, and then when they come home to see how spaceflight has changed that system.
So it sounds like when we go to the moon or Mars, we'll know, will they be able to hit the ground running, or will they need a while to get their land legs under them?
Yep, that's exactly why we're doing that experiment. Yep.
Very cool. Well, Steve, thanks so much for joining us.
Oh, you're welcome.
To learn more about NASA's Human Research Program, be sure to follow @NASA Johnson on social media, and be sure to watch NASA TV on April 3rd to find out which astronauts are traveling to the moon, putting some of this amazing research to good work. That's Space to Ground for this week. I'm Chelsea Bayarte. Thanks for watching.